Hey cool cats and kittens. Today what we're going to do is we're going to come up with a strategy on solving all of our trigonometry problems. What I mean by that is I'm going to give you a little flowchart diagram which you just need to remember in order to solve all your miscellaneous problems for trig. So first of all, what I'm going to do is I'm going to write our title up here. Also, I'm going to take a photo of these notes and put it on the Google Classroom just so you have a copy of this flowchart. Now, when we're talking about trigonometry, what we're really looking at is right-angled triangle questions and non-right-angled triangles. Okay? So right-angled triangles always have a right angle in them. Okay, so basically it doesn't matter how long or how short you can draw them, there's that little box in the corner. However, non-right angled triangles are a little bit trickier. They've got acute angles or obtuse angles, and there's no set way of solving them problems for now. Now, when we're talking about right angled triangles, we can split that into two examples. There are examples where you can solve using Pythagoras, and there are examples where you solve using SOHCAHTOA. Alright, when you're solving those Pythagoras problems, you always have two of the three sides that you're given. You'll either be given something like this, where you need to find the hypotenuse. That's when you use a squared plus b squared equals c squared. Or you'll be given something like this, where you have the hypotenuse and you're given one of the shorter sides, and then you'll need to find the other side, where you'll be using the formula a squared equals c squared minus b squared. Okay? On the flip side, when you're solving for SOHCAHTOA questions, for SOH, you'll be given a right angled triangle. You'll have like something like this. You'll have the angle there, and then you'll be given the hypotenuse. Okay, that's for using SOH. This one you'll be using CA, because when you're labeling this, this is the adjacent and that's the hypotenuse. Likewise, how this is the opposite and hypotenuse. And then the tan questions in a right angled triangle, you'll be given something like this. Okay, where we don't know the angle, but we know the opposite, we know the adjacent, and so you're using TOA. And so that's what we're doing for trigonometry with right-angled triangles. For non-right-angled, we can use the same split. Okay, so you've probably remembered you've got the sine rule, okay, where it's a over sine A equals b over sine B. It also equals c over sine C, but really we just need two of them to work out our missing side. Or we just flip both of them and have sine A over A equals sine B over B, generally when we're trying to find an angle. Now, one quick example of this is 13, let's just say this is 40 degrees, this is 70 degrees, and we don't know what that is. Alright, so what we do is we match the pairs. So what Mr. Finicum has kind of described this to you is when you have some cross pairs, alright? But another way of noticing the sine rule is when you circle these pairs, what you can do is draw a little aeroplane as well. Okay, so remember, for the sine rule, we can draw planes to solve our problem. Then we go x over sine 70 equals 13 over sine 40. We balance our equation, and then we can just type this into the calculator to get the solution. Okay, on the flip side, if we have another triangle where we're finding a missing angle, okay, so let's just use the same numbers, I guess. Then again, when we cross our pairs, we can draw a little plane, and so we can work out that sine x over 17 equals sine 40 over 13, and then we can also solve this problem. And then to solve this, we also need to use inverse sine. Now, what we haven't touched on is the cosine rule, okay? So what we're going to do is we're going to give you two examples of that, where c squared equals a squared plus b squared minus 2ab cos c, all right? And so this is when we've got two sides and the included angle, all right? So let's say this is 13, this is 15, and this angle is 40 degrees, all right? We can use this formula when we're solving this problem. So we just label A, B, C, and C, all right? Remember, capital C is your angle and little c is your missing side, and you'll be able to just plug it into the equation to solve that. Our last formula we need to remember is cos C equals A squared plus B squared minus C squared over 2AB, and that's an example where we're given the three sides, so let's say 5, 7, and 6, and we want to find the included angle between here. Alright, and so we would just label this A, B, and C. If you want to find a different angle, you would just rename these. Let's say we want to find this angle here, then I'd call this A and B and that's C, just so I keep my formulas the same. Okay, there's one more thing also from non-right angled, and that's the area of a triangle. That's where you use half AB sine C. Okay, and that's when you have the two sides of a triangle. Let's just call this 80 degrees. Let's call this 15, and that's 7. And all we just need to do is type half times 15 times 7 times sine 80 to work out the area of a triangle. So these are all the formulas you need for trigonometry. These ones are in your formula sheet. Okay, and if you remember all these, you'll be able to tackle any of your miscellaneous questions. So what we're going to do is we're going to have a go at some of these miscellaneous questions. What we want to find out in this one is the dimensions of a block of land. All right, so straight away, what we're given is we're given a quadrilateral, but we are also given this dotted line which helps us split this into a triangle. So what I'm going to do is, if I'm trying to find out x correct to the nearest meter, I would first of all draw my triangles separately, put in the information that I need, and then solve my problem. Now, straight away we can see this is not a right angled triangle, so Pythagoras and SOHCAHTOA is out the door. Secondly, we can see that we're given 3 sides and 1 angle, so that means we're using the cosine rule. Okay, so what that looks like is before we pick the right cosine rule, are we trying to find a side or an angle? Because we're trying to find a side, we need the cosine rule written like c squared equals a squared plus b squared minus 2ab cos c. What I'm going to do is I'm going to write, okay, that's a, b, that's c, and that's capital C. So now I can just start substituting. 320 squared plus 210 squared minus 2 times 320 times 210 times cos 70. Type all that into my calculator. Make sure I close the bracket, and I've got this huge number here. One thing I will remember is that this equals c squared. So to find the letter by itself, I'm just going to square root both sides, and I end up with 317 to the nearest meter. Now, as soon as I've done that, what I'm going to do is I'm going to add that into my diagram, because that will help us find our next problem. The next problem, we can draw a new triangle. All right. We know that this is 317, we know that that's 38, we know that that's 82. Because we know the angle sum of a triangle, we could work out this last bit, but let's read the question and see if we need that angle first. What is the length of y? Okay, so what we can start doing is we're going to hang on. If I do my crosses, you'll also notice that I can make a plane out of that, so I'm going to use the sine rule. Now, it's important to know the sine rule. When you're using the different formulas, put the unknown at the top. Okay, what I mean by that is you've got the two formulas a over sine A equals b over sine B, or sine A over A equals sine B over B. Because our unknown side is at the top, what I'm going to write is y over sine 38.
Anyone feel like an early lunch break?
So what we're going to do is write y over sine 38 equals 317 over sine 82. To solve the equation, we're going to get y equals to 317 times sine 38 over sine 82. And then we're going to type that all in our calculator. Make sure you close the brackets, like we always said. And that just gives us our missing distance, which is 197.08. All right, so that's in meters as well. Correct, to the nearest meter, 197. Whoops. Okay, so that's that first question. We solved that because we knew there were non-right angle triangles, so we needed the sine rule or the cos rule, and then we just used the appropriate rule to get our appropriate answer. So moving on to our next question. Now, this question you may have seen before, and there's actually many different ways of solving it. What I would do is solve it the easiest way I recommend, but if you get the same answers as me, and you've done it a slightly different way, it doesn't mean you're wrong, it just means you've done a different method. Now, what I would do is, first of all, I would look at this question in true triangles like as we did before. Okay, so Madison measures the angle of the elevation to the top of the wall is 32 degrees. She walks 10 meters horizontally, measures the angle again, and finds that is 51. Now, what I've done is I have separated this into two mini questions. The reason I've done that is because there's actually a lot of information you know about this question even before you start. Because if we're looking at this angle here, we know that that's a straight line, and that's 180 degrees. So if we do 180 minus 51, suddenly we're given this angle here, 129. The angle sum of a triangle is 180, so I'm going to find out the missing angle up here, and that's 19 degrees. Now, there's two parts to this question. The first part kind of needs to work out at least one of these two distances. So what I'm going to choose to work out is this one here. And the reason behind that is you'll be able to spot soon. So here in our triangle, we've got one side here, and we've got one cross pairs like that. We can draw our airplane. You'll notice we kind of can find that out, but I'm not going to. And so here we've got x over sine 32 equals 10 over sine 19. We're going to solve this problem by timesing both sides by sine 32. So we've got 10 sine 32 over sine 19, and that's going to give us x. All right. Now, because that's not the height of the wall, what I'm going to do is add a couple of decimal places so I have my perfect answer. So I'm going to write 10 sine 32 divided by sine 19, and what I'm going to do is I'm actually going to round it to 3 decimal places. Okay, and the reason I've done that is because this isn't my final answer. What I want to do is get the answer as close and perfect as possible, so that's why I've decided to round to 3 decimal places for now. The next thing I'm going to do is I'm going to draw a new diagram. Okay, so what I know now is, hang on, this is 90 degrees, this is 51 degrees, and this is 16.277. I'm going to find out what h is. Now, back when we drew our diagram, this was a non-right angle triangle, so we had to use the sine or the cos rule, but this is a right angle triangle. So what we can use is we could use SOHCAHTOA. So ignore the h, that's the height of the wall, that's not my hypotenuse. We all know that this is our hypotenuse, this is just the opposite. So what I'm going to use is SOH, because sine 51 equals to my opposite over my hypotenuse. Okay, now you got to be really careful. Just because this is the letter H doesn't mean it's the hypotenuse. This was my opposite, and that's why I've written it as so. You'll probably go, hang on, I know how to solve this. I just need to times both sides by 16.277. So 16.277 times sine 51 equals h, my height of the wall. So I'm going to use my answer, which before was 16.277, times sine 51, and the height of the wall is 12.64, which to the nearest meter is 13 meters. Okay, so girls, some of you might have done it a different way. Some of you might have found this one and then used SOHCAHTOA with that. You would still get the same answer. And that's why it's important to leave this to the next few decimal places, because if I just did 16 times sine 51, you'll notice I get 12.4, which is slightly less rounded down to 13, and that would have gotten you the wrong answer. So be as precise as possible, unless you get to the last step, and that's all you need to do. Okay, so this question is very similar to the question before. So what I would prefer you to do is put down all the information as possible. So we can actually work out this angle here, because 180 minus 7 minus 144 gives us this angle. We can also work out this angle here, because 180 minus 144 gives us that angle. We can also work out this last angle here, because 180 minus 90 minus 36 will give us this angle. And we've already actually worked out so much bits of information before we even answer the question. You'll see question B asks us to find angle DFE. We've already done that. All right, but we'll work through the questions now. So question A asks us to find the length of DF, and that's this distance here. So what I'm going to do is I'm going to draw a separate diagram. I'm going to label DF as X. What I know is this is 8, this is 144, and you're like, hang on, two sides, two angles. I can use the sine rule. So X over sine 29 equals 8 over sine 144. So what we're going to do next is solve this times sine 29 by both sides. 8 sine 29 over sine 144. 8 sine 29 divided by sine 144 equals 6.598 to two decimal places is 6.60. Okay, and that's in meters. Alright, so what I would recommend is you put that information in your diagram when you're moving on to the next question. So B, we've already found this to be 36 degrees. That was an easy question. And find the length of FE here. Now, again, we've got ourselves a right angle triangle. You can actually make your life easier by just remembering that you're like, hang on, right angle triangle means I can just use SOHCAHTOA. Using the sine rule, right, with this question will actually work, okay? But what also works a little bit better is just using the cosine rule with our alternate and hypotenuse, okay? So what I'm going to do is I'm going to write cos theta equals A over H. What I'm going to do is write cos 36 equals X over 6.60. And then I'm going to type in my calculator 6.60 times cos 36 to find me X. And that's just going to equal to 5.34 to two decimal places. So that's how I can work out those 2 points. Yep. Last question, survey of a park. Now, this one's a little bit trickier because there are lots of parts to this question. It's talking about a path that's proposed from B to D, so that's this distance here. It's talking about a fence that goes from B to C to D, so this is the fence. There's 2 parts to the fence, so let's go through and work out bit by bit. So again, I'm going to separate my triangles. So I've got this distance here, 41, 35, this degree 99, and I want to work out my unknown distance. 3 sides and an included angle you need to know is the cosine rule. So let's type c squared equals a squared plus b squared minus 2ab cos c. That's going to then go 41 squared plus 35 squared minus 2 times 41 times 35 times cos 99. And then we're going to type that into our calculator. 41 squared plus 35 squared minus 2 times 41 times 35 times cos 99. I've put all of that in brackets. Make sure I square root my answer, and then we get 57.92, which is to the nearest meter 58. Now, because this question has told us to the nearest meter, now we can round off to the nearest meter. I'm going to put that bit of information in there as well before we do question B. So question B asks us to find the required length of fencing. So here I'm going to draw my separate triangle up the top, like so. I'm going to put in the information I know, 74, 37. You can work out this angle, because that's the angle sum of a triangle. So we're going to do 180 minus 37 minus 74. That's 69 degrees. So let's add that in there too. This is going to split off into 2 sine rule questions. Because if you want to work out this distance, okay, remember we've got our airplane. Let's call this y, and let's call this z. Okay, so y over sine 69 equals 58 over sine 74. Okay, and I can just type this into my calculator. 58 times sine 69 over sine 74. 58 sine 69 over sine 74. Close the brackets. Equals 56.32. Before they said to the nearest meter, so I can just write 56 meters. Now that is the distance for y. The distance for z is going to be z over sine 37 equals, again, 58 over sine 74. If you want to, you can also use 56 over sine 69. It'll actually give you the same answer, but I'm just going to keep it simple because I've already got those 2 points. So z equals 58 times sine 30, sorry, that's the 37, I can't read my own writing, over sine 74. 58 sine 37 over sine 74. And that is 36.3 meters, which is the same as 36. So the length of fencing, we're going to add these 2 together. 56 plus 36 is 92 meters fencing. Okay, so the last thing we need to find is the area of the park. Okay, now we're starting to run out of room. Hopefully you'll notice that there are 2 triangles. What we can do is use these numbers that we've just received. So I'm going to draw the examples up here. All right, I'm going to call this T1. Okay, so before we said that these distances was 36. Okay, so this one here was 36. This one here was 56. And for the angle, we need half AB sine C, which is the included angle. So I'm going to write 74 in there. Now for triangle 2, I've got the other thing, but we've got numbers which we already know. So I'm going to write half times 56 times 36 times sine 74 for my first triangle. And I'm going to do this all in one go. So half times 41 times 35 times sine 99 in our second triangle. And when we type all of that into our calculator, half times 56 times 36 times sine 74, okay, plus half times 41 times 35 times sine 99, we will get the combined area 1677.61 to the nearest square meter, 1678 meters squared. Okay, and so that's how we would solve all these miscellaneous problems.